Previously, we laid out the groundwork for the instrument pack, soldered together the protoshield for our platform, and we've laid out how all of the sensors and devices will be attached. Now, it's time to actually come to our senses and put this thing together.
Oh, that was awesome and horrible, but mostly awesome.
First up is the temperature sensor. The sensor we are going to fly is actually different than the one we tested back in March.
I realized only after I purchased it that it was only rated down to minus 25 degrees. That's not quite low enough for what we believe we will encounter on this flight. So we had to change it out to this one. This is a DS18B20 temperature sensor from sparkfun.com, rated to minus 55 degrees Celsius.
To start, we cut out a little square strip board, a pre-printed circuit board that we bought from Radio Shack. As the name implies, there are pre-printed strips of copper connecting sets of holes. We cut a piece that would be able to hold the 3 pins of the temperature sensor and connect them to a 3-wire socket.
To protect the temperature sensor from being damaged from the heat of the soldering iron, I clipped a heat sink onto the pins between the sensor itself and the board that we were about to attach it to. I then soldered the 3 pins of the sensor down. Next, I soldered the 3 wires leading to the socket to the other side of the board. This would mean that the temperature sensor could be mounted to the outside of the capsule, and the wires would lead back in, connecting it to the rest of the instrument pack.
While Dad was soldering the sensor down, I got the breadboard ready to actually test it. We followed the wiring diagram from builder.org, hooking up 3 pins, as well as a 4.7K ohm resistor bridging the data and power pins. When the sensor was ready, we connected it, and fired up an Arduino sketch from builder.org to test it. It worked great. The sketch would take a temperature reading in Celsius 10 times a second. Dad would hold his fingers on the sensor, and we'd watch the temperature go up. He'd then let it go and watch it come back down.
Getting our sensor mounted to our custom breakout board was only half the battle, though.
G.I. Joe!
Have you been watching reruns again?
Maybe?
Anyway, the next part was to get the sensor wired up to the protoshield.
We consulted our design, and then laid out the pieces we would need to assemble. The protoshield, the sensor mounted to its socket, a 4.7K ohm resistor, and 3 connector wires.
We started by mounting the resistor, which Katherine did her usual terrific job with. I think I'm going to have to start calling her Iron...
Don't say it! That's too cheesy, even for me. Next, we worked on getting the wires that would connect the socket to the rest of the board, and then the socket itself.
There were a few frustrating parts to this step. First, we had to bridge the connections using almost nothing but solder, and that proved to be more difficult than I thought. Next, I found that when we soldered a wire down, the casing covering it was getting melted on the other side. To compensate for the now exposed lines, we had to resort to some shrink tubing and our heat gun.
Dad would cut a small piece of tubing just long enough to cover what had melted and slipped it onto the wire before we soldered it down. After getting it soldered on, he would slip it over the new joint, and then use the heat gun on it for a few seconds to shrink it onto the wire. Here's the finished board, showing all of the shrink tubing attached.
Now for the big test. We mounted the protoshield to the Arduino and fired up the temperature sensor sketch again.
And it worked like a charm. Next time, we'll be attaching a barometric pressure sensor.
I'm waiting for the obligatory being under pressure joke.
Nah, that's too easy.
Oh, come on. How many times in your life will you be working with a pressure sensor? You gotta say it.
Are you pressuring me here?
No, I'm just...
Hee hee, gotcha.